Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. So today I want to talk about how to solve for any variable easily. That's the title for today. So basically what I'm talking about here is, and I'll do a couple different examples. Let's say you want to look at redoing or solving for a different variable in a science formula. All right, so I know this is math, but you know when you apply math, you get science. So let's say force equals mass times acceleration. Right? So there's actually a way to write this so that I can easily solve for acceleration or mass without really having to do any solving. Okay? And before I show you this, real quick, if you haven't already gotten this, it's an awesome free guide. It's my 5 math mistakes everyone makes and how to avoid them. It's on my website, Myers Mathematics. You just go there, subscribe, and you get the awesome free guide delivered to your mailbox. So go check that out. But here's what you do. All you do is, okay, this is mass and acceleration multiplied. So I'm going to put them side by side here. Okay? And then I'm actually going to put the F on top. Now, I know to put the F on top because I'm going to make a triangle out of this. And I like to call this the Triforce method. Okay? The Triforce method. So I can interpret how to solve for any variable by creating a little Triforce. And I knew to put the M and the A on the bottom because they're being multiplied. If they're on the bottom, force equals mass times acceleration. If I want mass, it's force divided by acceleration. And then if I want acceleration, it's force over mass. See how that works? Let's try another one. What if it was dividing? So let's say the DMV formula, density equals mass over volume, right? Well, you start with the M and the V. You start with the two things that are already together, and that's how you know how to make your triangle. So the M and the V are already together. That means the M's on the top, the V's on the bottom, and the D can go over here. Right? And then I make my triangle. There's my Triforce. So if I want mass, it's actually density times volume. If I want mass, it's density times volume. If I want volume, it's mass over density. Right? And then of course I already have it solved for density. So there you go. Right? Let's talk about some math formulas that you could use this on. So for instance, let's say tangent. Right? So now we're jumping ahead a few grades here. We're in trigonometry or geometry or calculus, pre-calculus, something like that. So let's say tangent. And I usually write little thetas on here, little Pokeball things. But just, you know, to keep it nice looking, I'm going to leave out the theta. It is tangent of theta, but, you know, it's whatever. You know what I mean. Tangent equals sine over cosine. There's a really important formula to know when you're doing like identities, when you have to like prove identities in trigonometry. Because what if I need to, you know, solve this for a different letter? Well, I just make a triangle out of it. Sine, cosine, tangent, right? And then I have my triangle here. So now sine over cosine is tangent, okay? But sine over tangent is cosine. And then also tangent cosine is sine. So if I said tangent cosine over cosecant is equal to 1 minus cosine squared, right? Like if I wanted to prove that identity. Well, I could say, okay, well, tangent cosine over cosecant, how am I going to turn that into 1 minus cosine squared? You might actually want to start on the right-hand side, and maybe that'll be a little easier. But 1 minus cosine squared would be sine squared. And then you could say, okay, well, that's, okay. And then that's that. Cosecant is 1 over sine, so this would be tangent cosine sine equals sine squared, and then you're stuck. You're like, oh, what do I do? Well, tangent equals sine over cosine, so if you make this little triangle, you can see here, oh, tangent cosine equals sine. So this is sine times sine equals sine squared. And there we go. Now we've proven the identity. Okay? So it makes identities proven a lot easier. Okay? And then there's other formulas too. Now, this does not work on, let's talk about for a second what this does not work on. So does not work when you have, like, let's say y equals mx plus b. Right? Because I'm adding. If I'm adding or subtracting, then it's not going to work. It has to be a multiplied or divide. Okay? So it wouldn't work on y equals mx plus b. It wouldn't work on, like, the trig formula, the Pythagorean trig formula. So like sine squared plus cosine squared equals 1. Like, it wouldn't work on that either, right? Because I'm adding and subtracting stuff. Also, it kind of, so this is does not work. This is does not work. I can get this to, I can get the cloud to work here. Goodness gracious. Okay. Does not work. Now, it kind of works. Let me change to a fun color here. Kind of works on formulas where you're multiplying or dividing more than just, you have three things in an equation. So, for instance, let's say volume equals 4/3 pi r cubed. Well, now we have a bunch of things happening, right? So it kind of works for something like this, but you have to figure out what you're going to group together because we have more than 2 or 3 things now. So if we wanted to make a little triangle out of this, it depends on what you want to do with that triangle. So let's say there's really only 2 variables here, right? So I could say maybe like 4/3 pi is one thing, and maybe r cubed is one thing, and then v is the other thing. Okay, well then if I'm doing it like that, then these two are being multiplied. So I would say 4/3 pi, r cubed, and v. So I could do it like that. And then I would say, okay, well if I want to solve for r cubed, it would be volume divided by 4/3 pi. And then I could take the cube root of both sides. I don't know why you would want to solve for 4/3 pi, but if you did, it would be volume over r cubed. So, that could work there as well. So it kind of works on other formulas. It's not as clean and crisp on formulas where you're multiplying and dividing more than a couple things. Okay? So it will work on other formulas that are a little more complicated as long as there's no multiplying or dividing, adding or subtracting. It does not work if there's adding or subtracting. It kind of works if you're multiplying or dividing several things. And I all of a sudden switched to blue, and I didn't even realize. I thought I was using rainbow colors. I must have accidentally switched back to blue, and I didn't even realize it. It's probably because blue is my favorite color. All right, so that is the trick. That is the method, how to solve for any variable easily, okay? And I couldn't think of a better way to describe it without using a ton of words. So I'm sorry if the title was a little misleading. It wasn't my intention. But yeah, I was trying to think of a better way to come up with a title there. If you have a better idea for a title for this video, let me know in the description below, and I will change it to that title. And then also let me know if there's a formula that you're not sure how to turn into a triangle. Right? Or maybe tell me in the comments if you think of a cool little formula that I missed that I should have included, and maybe I'll make another video later on that has more math examples in it that you can use for different math classes and things like that. But in the meantime, I hope this was helpful. And again, if you haven't gotten that free guide, it's the 5 math mistakes everyone makes and how to avoid them. It's on my website, myersmathematics.com, MYERS, just like the channel. And then, of course, if you want to see more videos like this, you can like and subscribe and do all that kind of stuff too as well. All right, and I hope to see you guys in another episode really soon. Myers Mathematics out.